So let's look at node affinity, right? This is similar to, right, node affinity is similar to NodeSelector. But why this offers hard selection, and hard selection means wherever you direct your ports to based on the label, it's going to go there. And let's say, for instance, if you direct it to a particular label, you've labeled the node, right? If the node does not exist, if it exists, it's going to go there. If the node does not exist, this pod, the pod that you schedule on it will not just get scheduled on any node, right? That's very hard selection, right? But unlike node affinity, what you can do actually is you can specify fine-grained control, fine-grained control. So you can have hard or you can have soft affinity. This hard is go here, go to this node that I scheduled you on, right? This pod A, go to this node. And if it is soft, right, whatever node you find, even if it's node B or node C, let's say this is node A, go to this. And if it's soft, right, it will specify a soft node affinity. If you can't find node A, go to node B or node C, it's fine, right? But this should be the first thing you should go to, which is the soft, right? Let me explain it again, right? In add node affinity, right? What you should do is whatever I tell you to do, pod, wherever I schedule you to, pod, this is your node, come here. It's the required, right? You have to come here by all means. This is where. If there is no other node, don't just come out. Don't be scheduled at all, right? But in soft, right? All right, even though this is the preferred node, node A is the preferred node, right? If you can't be scheduled on node A as a pod, right? If there are other nodes, go there. If it's node B, don't worry, you can go here. It's still very okay. So those are the differences in there. You can put a fine-grained control on it, unlike when it's in this place. NodeSelector, it's not possible. So let's see that in action. So what I'm going to do now is I'm going to create a new manifest file for our node affinity. And first I've deleted everything except the labels of the nodes, right? So if I say kubectl get pods, nothing is here. If I say kubectl get nodes, and I say show labels, the labels are still there. So if you look at it here, we have disktype SSD and we still have app equal to db. Well, anyways, I'm going to use this disktype SSD in this example. So I'll clear the screen and I'm going to say vim01 and I'm going to say node affinity hard dot YAML, right? This is how we write it. And the first thing we want to do is say hi, and I'm going to specify this. API version is v1, and the kind of object we want to create is pod, right? And with that, we are going to write this metadata, which contains all the information about the pod. We would say metadata. I'm going to say the name of the pod is going to be pod A, right? That's what name I'm going to give it. And I'm going to write a specification. And this is where we are going to specify. Well, first thing, we are going to say affinity, which will tell a Kubernetes cluster that we want to write manifest file for Affinity. And there are different types of it. Don't forget, we have Node Affinity, we have Pod Affinity. In fact, we have Pod Anti-Affinity, right? And right here, I'm going to say Node Affinity is what I want to do, right? And I'm going to say required. This means I want a hard Node Affinity, right? This is required. We'll say required during scheduling. Ignore during execution, and you have to be careful with this. Make sure there is no typo in this, and let's see it. Required during scheduling, ignored during execution, and we have one here, and it's supposed to be ignored and not ignored. So this is ignored during execution, and we are going to go down. And next is we are going to say node selector terms. Node selector terms. And I'm going to explain this, right? Node selector terms, I'm going to say match expressions. Match expressions. We're going to say key, right? And we are going to say the key is disk type. Disk type. And we are going to say operator is in, and we are going to say values is SSD. Now let me explain this part, right? Now what this node selector terms means and what it allows you to do is to give a fine-grained control, like I said before, for node affinity. Now if we say key, which is the key for the label, remember the key is disk type, and the value is SSD for the node, remember that. And now we are saying operator is in. Now what this is going to do is going to say if this node selector matches that label that will give it, if the key inside is SSD, then you have to put the pod inside that particular node. But we can also do something which we will try after this. We can say not in. And what this not in will do is it's not going to schedule this pod in this particular, if the disk type is not inside this place, it will never schedule it on this node. Instead it will schedule it on another node in that cluster. So you can see how this is powerful. Like node selector, you can't do this. So I'm going to say this, I'm going to remove it, and right here we are going to write about our container, right? And make sure this is under Affinity, right? And I'm going to say containers, and I'm going to give the name of my container. Don't forget this. I'm going to say this name, and I'm going to give it as my container. And the image is going to be Nginx, right? And if we look at it, right, we say this is required, which is add selection, node selector terms, key disk type in this. And I'm going to save this, right? And I'm giving it pod A, right? So if everything is done right, let's go here. And we are going to, all right, I always make this mistake, don't be like me, escape. And right here, this is the time, kubectl, apply -f. I'm going to say 01, node affinity. And it's saying kubectl apply. Yes, it has to be apply and not this apply, right? And the pod has been created. And let's say kubectl describe, okay, not, let's just say get pods. And I will say all wide to give us more about it. And if you look at it, our node that has this is mini cluster worker, right? That's where it's going to schedule no matter which other nodes are there. Now let's look at not in and see what's going to happen. So if I say vim, that same one, I'm going to say this, and it's going to supposed to be vim 01, right? And now I'm going to say something. I'm going to say not, okay, this won't work. So I'll first delete this other one. I'll say kubectl delete pod. I'm going to say pod A, that's the pod. And then I'm going to change this one. I'm going to clear the screen. I'm going to say vim 01. And I'm going to say this. And I'm just going to say, let me just name this to B. I'm going to name this to B. Right? And I'm going to come here and I want it to be not in. I want it to be not in. So come here. And I'm going to say not in. So I don't want it to schedule it on this node, right? It can schedule it on another node, right? But not on this node with this label disktype SSD. And I'm going to save it. I'm going to say escape. I'm going to save it. And then I'll say kubectl apply -f. I'm going to say 01. And .yaml. I'm going to say enter, and it has been created. And say kubectl get pods whole wide. We should see now. You see, it's a mini cluster worker 2. It's not. It will never be scheduled on it, and no matter what, it will never. So this is hard, right? So the next one we are going to look at is we are going to look at the soft part of it. So now I'm going to say vim 02. This time I'm going to say node affinity soft. Let's just call it soft. And I'm going to open this. And right now I'm going to start, say hi, say API version V1, right? And I'm going to say kind is pod as usual, and I'm going to say metadata. I'm going to say metadata, which will contain information about the pod. I'm going to say name should be pod soft. Let's just call this pod soft. And I'm going to say specification is going to be affinity, right? And this time around, what we are going to say is node affinity as well. And now it's going to be preferred, right? Preferred during scheduling. And ignore during execution. So ignored during execution. And don't forget, please, that this, be careful of any typo. So this is soft affinity, is not required. It doesn't matter if it likes, it can put it in that node, and if it doesn't see it, can schedule it somewhere else, right? And we're going to say wait. Now, this wait means this weight is between 1 and 100. This weight means it is very weak. If you like, do it. But if we put it in something like 100, it means it's just like hard. It's just like this is required by all means. If this node is available, it's not hard though. But if this node is available, this is where we want. Right? But even if you don't see it, all right, go to another node. But if this node is actually available, if it is available, put it there. That's what we want. But this one doesn't mean it's weak. Whether it's available, whether it's not available, just put it somewhere. Right? That's so. Please, it's different from add. That's what wait means. Right? I'm going to say preference. Right? I'm going to say. You can see how it's different. Match expressions. If you remember, for hard, it wasn't preference, it was NodeSelector terms. Right? So this time we'll say match expressions, and we're going to say key, and it's the same thing here. Key, we're going to say key is what? disk type, and I'm going to say operator. And in fact, let's use this one. Let's say key is app, and let's say operator is what in, and we're going to say values is what db. That's what we put it. App is db, right? And then we are going to say it's supposed to be under Affinity. Please make sure that container. And I'm going to say the name is MongoDB. And we are going to say the image is Mongo. Please. Yeah. So Affinity. Let's look at it. If it's in the same place, Affinity and containers, right? I'll explain the weight one more time. Weight is, if this is weak, right? It doesn't matter if it finds this node with this app DB, right? If it doesn't find it, no problems. But when it is 100, it means if it is available, please put it on it. Except it is not available, then put it on another node, right? That's it. But this one is weak now, so it doesn't matter. Just want it to do that. So let me say escape. We'll see Q. We'll save it. And if we've written everything the right way, if we do kubectl apply -f, and we say 02, and this is created pod soft for us, and we say kubectl get pods o wide. And if we look at it, it's in mini cluster worker 3.